Okay, so lots to cover here with polynomials, the end behavior, multiplicity, and factored form being the main three. What I've done here is written an equation in what's called standard form, and a lot of people are used to seeing polynomials in this form versus factored form, which actually is what the highlight of this video is going to be. But both forms are useful, and both forms you're going to be graphing from. So let's talk about the point and the purpose here. So what I want you to understand is that these are going to provide a similar graph, what I have right here, because this one is a fourth degree polynomial, and the one down here has 4 factors or 4 solutions, so it is also a fourth degree polynomial. So think about it as if I asked you to multiply all these out together, it would look something like that. Okay, so they're pretty similar in terms of that. Now, this one is way easier to graph with, because if you're in factored form, you are immediately going to know your x-intercepts. Remember, to find your solutions, you're setting y equal to 0, and then you're solving all of these. So what happens is when I set the first factor equal to 0, I would get an answer of a, and then this factor would be b. So these right here, whatever numbers are in these spots, these are going to be my x-intercepts. And that's going to help you graph it a whole lot easier. But another thing that's really important when graphing is something called end behavior. And what end behavior means is basically, what is the graph going to look like on the ends of the graph, like on the extreme left or on the extreme right. So the best way to talk about end behavior of polynomials is to focus on parent functions that you already know. We should all know that y equals x squared is a parabola facing upward. But when we put a negative on that parabola, on that x squared, it's going to end up reflecting it so that it faces downward. This end behavior is basically asking what is happening on the left and what's happening on the right. So you're looking at the arrowheads, you know? So like some people describe it as it's rising on the left and rising on the right, or they say the graph is approaching infinity on both sides. This one would be approaching negative infinity on both sides. So the cool thing is that anything that is an even exponent, right? Anything, even if it was like x to the 26th, it's going to have the same behavior on the ends. So it'll be going up on the right and up on the left if it is a positive term or coefficient, and if it was a negative function, then it would just be going down, down instead. So what would happen in the middle is Lord only knows what. These things can get pretty funky, as you'll see throughout the chapter, but if the leading term, and I'll explain that a little better in a second, but the leading term of the equation is an even exponent, and positive, it's going to go up, negative is going to go down. So what if it's an odd exponent? Well, do you remember the graph of x cubed? So this is another parent function. So all odds are going to sort of match this behavior if they're positive, and if it's negative, same thing, it's going to get flipped. So down on the left and up on the right, or if it's negative, up on the left, down on the right. I think I just said the same thing twice, but I drew it correctly, so you get the idea. Once again, any wacky-do stuff can happen in the middle, but on the ends of the graph, the ends, that's what's going to be happening. So the official way to write this, like a good way to write this, is with some fancy formal notation. The way we say it is, as x approaches infinity, y approaches something. And as x approaches negative infinity, y is approaching something. So you are filling out that something. An arrow in math just means approaches. And so you're basically reading it as x approaches infinity. And what that means is if I'm looking at a graph, x approaching infinity means I'm looking at the right side of the graph. So like on this one, the right side of the graph is going up. Well, where is up in math? Well, it's negative infinity. And on this one, if x is approaching negative infinity, it's like you're going this way. So as the x's are getting smaller, we're on the left side of our graph. And on this one that we were doing, it is going up. So if they're both going up, you're filling in a positive infinity for these. But like on this one, as x approaches infinity, so this just means on the right, the arrow is going down. So we would say negative infinity. On the left, it's also going down. So that's what end behavior would look like. So these are a little trickier, right? Because they're not going to match. So you got to be careful with your x's. I'm sorry, your rights and your left. So as x approaches infinity, that would mean the right side of the graph. So on the right side of the graph, which would be this arrowhead, it's going up. But on the left, when we put a negative infinity, the y is going down. So hopefully that makes sense. So let me finish out our last little box here. So on the right, this one's going down. And on the left, this one's going up. All right, so this is our formal notation for end behavior. And you might be thinking, so, okay, why is that a big deal? Well, it's a really big deal if I were to give you an equation that you didn't know what it looked like, immediately. So let's say we're not going to graph this right now. Plus, 5x to the fourth minus 3x squared plus 11. Okay, let's say I gave you this crazy function and I didn't give you a calculator. Well, if you understand end behavior, you will look at the leading term, which the leading term is going to have the highest degree, the highest power. So this is our leading term. And I just covered up what the exponent was. That was smart. Okay, so if that's my leading term, not just because it's in the front, by the way, but because it's the biggest exponent, this one is negative, and the exponent is odd. So I know if I compare it to the things above, I could either look in the boxes over here, or I could come to these graphs. It'll match a negative odd graph like this one. It'll be the same as this. So I know no matter what junk is going on in the middle, on the left it's going to be going up. Maybe some funky stuff happens here, but on the right it's going to be going down. So how do we use that for factored form? So factored form is absolutely my favorite to graph, and I think it's the easiest. So let's make something up. How about negative x minus 1 squared? Actually, we won't go there yet. Let's do x minus 1, x plus 2, x minus 3. All right, so let's say that we were asked to graph this. All right, well, what I would do is, the first thing I would do is go ahead and find your x-intercepts, because they are staring you in the face, Set these to 0, and your x-intercepts are going to be the point 1, 0, negative 2, 0. Why are these the opposite of what I see? Well, remember, we're setting each one equal to 0 and we're solving, so the sign's going to change when you take them out. And if I graph it, 1, 0, 3, 0, and negative 2, 0. All right, so here's our intercepts. So if I didn't understand end behavior, I don't know how to connect the dots, right? I really don't. Like, I don't know if I'm supposed to come down and then up and then down. Like, maybe that's what it's going to look like. Or maybe it's like it starts from the bottom and then it comes down. Okay, maybe it does that. But if I understand end behavior, then I know which of those two is correct. Let me erase all these dashes. Okay, that was smart of me to dash it. Okay, so how do I do it? Well, let's look. So if I had multiplied this out, which I'm not going to because that's way too much work, but if you imagine multiplying it out, I have x times x times x. This would be like an x to the third equation. But actually it would be like a negative x to the third equation because of the negative in the front right here. So I know this is going to match, just like the one that we did a second ago. It's going to match like this one. So it'll go up on the left and down on the right. And then we just like play connect the dots here. Yay! All right, so a couple things here. So I don't know how high and how low these go. If I wanted a little bit of assistance to figure that out, I could find my y-intercept. Remember, the way you find a y-intercept is to plug in 0 for x. So I'm going to do that. So let me see where my y-intercept is supposed to be. So 0 minus 1 times 0 plus 2 times 0 minus 3. So I have a negative of a negative 1 times a 2 times a negative 3. Lots of negatives going on there. So I think that all turns into a negative 6. So really and truly, 1, 2, 3, 4, 5, 6. If I want this to be accurate, I should have gone like, I'm going to use a highlighter to do this. I should have gone steeper and then up and then down. It would look more like that. So that's how you graph in factored form without a calculator. Now, there's a concept above that says multiplicity, and you may be wondering, well, what the heck is multiplicity? She wrote the word at the top, but she's never mentioned it. Multiplicity is going to be how many times a solution shows up as a solution. How many times does a factor show up? Well, in this case, notice there was only a 1, a -2, and a 3. We didn't have another factor that matched it exactly. So all of these are said to have a multiplicity of 1 because they're unique solutions. And when you have a multiplicity of 1, you are going to always cross through the axis, just like you see happening right here. But when a solution shows up more than once, like the following. Let's pretend it was like x minus 2, x minus 2, x plus 3, something like this. Okay, and let's do one more for funsies, x plus 1. Okay, so let's say we had all of these given to us and someone said graph. Well, this may be the way it's written, or actually more popular. What you would see is somebody at our level of math would probably go ahead and write that as x minus 2 squared. You know, they would like condense that. So you'd be sort of looking at your exponents and then thinking, what's the significance of the exponents? This is for multiplicity's purpose, because the solutions for this, if we were to go through and find our x-intercepts, our solutions, they would be 2, 0, but 2, 0 would show up twice, right? Because of that squared. It would be the point 2, 0, 2, 0, -3, 0, -1, 0. So when you have something show up twice or even 3 times, that's said to have a multiplicity of 2. And that actually is important. It means something on the graph. This is a multiplicity of 1 because it only showed up once, multiplicity of 1 because it only showed up once. So what did we say earlier about a multiplicity of 1? Well, at these points, you are literally just going to cross through the axis like normal. There's nothing really special about it. So I'm going to cross through the axis here. I'm going to cross through the axis here. But at 2, something special happens. Whenever you have a multiplicity of 2, you actually bounce off the axis. And so let me take a minute to write down the rules of multiplicity. So if you have a multiplicity of 1, you just cross through the axis. A multiplicity of 2, you do what's called a bounce. You'll see me demonstrate that in a second. If somehow one of these had had a multiplicity of 3, meaning an exponent of 3, you would flatten out as you cross. So you still cross through it, just like with the other odd exponents. But with the evens, you bounce. And the higher the number goes, the more you flatten as you do these things. So the pattern would continue. Like if I put 5, it would say flatten more and cross. A multiplicity of 6, flatten more and bounce. So you just keep going flatter and flatter. So what does this actually look like? Well, the one up here where it's supposed to bounce is the one with a multiplicity of 2. So right here, it's either going to come up from above and bounce this way off the axis, which means it touches the point but it doesn't cross through, or it could come from below and bounce, except it would actually touch it. Okay, so which one is it going to be? Well, guys, I don't know until I do my end behavior. Okay, so end behavior. So if I were to multiply this out, x squared times x, that would end up being how many, right? x, 2, 3, 4. It would be like an x to the 4th. And there's no negative in the front here, right? So it's like a positive x to the 4th. So if we go back up to our chart, positive x to the 4th. Okay, so positive x to the 4th. So it's an even exponent and it's positive in the front. So it's going to be going up, up, just like a parabola. Okay, so on the sides, it's going up on both sides. So I'm going to go ahead and just kind of start winging my graph here. It's going to go up on this side, up on this side. And then here we start to play connect the dots. These I can go through, right? Because we know we're supposed to cross through them. But when we get to this point, we don't cross through. We bounce and then come back up. Now, I don't know if I made that low enough. I don't know if I made that high enough. But once again, if I cared, I could plug in a 0 for all of these. 0 minus 2 squared, 0 plus 3, 0 plus 1, and I could do this math, which would be 4 times 3 times 1. So this is really supposed to cross like way up here at 12. So to fix that, there we go. It would look something like that. All right, so that's kind of how you could graph one of these start to finish. So I'll do one more example, which is just a little bit more complicated, so you can see sort of all of the what could happens. X minus 2 squared, x plus 1, x minus 4 cubed. How about that? All right, so that looks pretty heavy. So how are we going to graph this? Well, we're going to start by graphing our x-intercepts. Where are they at? At positive 2, there's going to be a point. And since there's an exponent of 2, it's a multiplicity of 2, so it's going to bounce. I'm just going to label it so I can graph it easier later. At negative 1, there's going to be a point, but there's no exponent here except for a 1, so it's just going to go through. So I'm not even going to label that because that's like normal. And then x minus 4. So at positive 4, there's going to be a point, but there's a 3 here which says you're supposed to flatten and cross. I'm going to put an F for flatten, FC, flatten cross. Okay, so now what? So now let's think in behavior. X squared times an x to the first times an x to the third. Well, how many x's altogether would that be if I multiplied them? It would be an x to the sixth, right? 2 plus 1 plus 3 is 6. So this is an even exponent, and in the front I see a negative. So if it's even and a negative, it's just like an upside down parabola. So that lets me know that this is going to be going down on both sides. Whee! All right, so now we just make up the junk in the middle. Let me go ahead and find my y-intercept now so I don't have to fix it in a second. So let's plug in a 0 for these and see what happens. Oh my dear Lord, it's going to be a huge number. We're going to have 4. I'm just doing some mental math here. I'm plugging in a 0. Plug in a 0. Oh my gosh. It's basically going to be whatever 4 to the 4th power is once you put all these together. So it's going to be like, goo, 64 times 4. I should have that memorized, but I don't. 256. Are you kidding me? Is this really happening? 1 times that times 0.43. Yeah, that's really happening. I'm not graphing that, folks. Okay, we're just going to say that's 256. So this thing would go shooting up way high. It would cross through here. It's going to bounce at the next point. That's why I label as I go so I don't have to think too hard later. And then it's going to come up. I'm not sure how high. Who knows? Then it's going to come back down, and when it does, it needs to flatten and then cross. So see the difference there? It didn't immediately cross. It kind of like levels out, almost like a cubic function, and then it goes down. So that is the speedy version of graphing from factored form, handling multiplicity and where it comes from, and then also how to do end behavior and use it to your advantage when graphing. So hopefully that helped you out and there are no questions, but if so, come and ask me.